Hello guys, welcome back to another video. In this video, we are asked to list the numbers from the smallest to the biggest. So we have 1/2 pi, 11 pi divided by 6 pi, and this integral. So the first thing you can see is that this integral can be evaluated. I mean, there is no elementary function to e to the negative sign of square of x. So we need to approximate the integral somehow in order to get those numbers listed. Of course, you can maybe say, we can take a calculator or something, but it's not fair. And this integral, I don't think it can be calculated or something. So let's approximate the integral. Here, what can we see is that we have the function is e to the sine of x. So we know some inequalities, which I won't prove in this video because it would get too long. You know the inequality e to the x is greater than 1 plus x for all the positive x. Okay, we know this. So maybe we should use something like that in our advantage here. So let me just write something that we will do, but I won't prove it because it would take too long. If you want me to prove it, just write it in the comments. I can make a video about that. So how will we use this, like e to the something? Because we have a negative, the following inequality can be said. E to the negative x is greater than 1 minus x and is less than 1 minus x plus x squared divided by 2 for x greater than 0. This can be proven, but I won't do it. As I said, the video would get too long. So why do we need this? So in the place of x, we can substitute sine. So we can get 1 minus sine squared of x is less than e to the negative sine square of x. And this is less than 1 minus sine square of x, okay, plus sine to the, so sine to the power of 4, because we already put sine of the square root of f, so this is to the power of 4, x divided by 2. Okay, what do we do with this? What do we do with this now? We can integrate both sides from 0 to pi. Why do we integrate from 0 to pi? Because let's just assume we have to do that because our integral is from 0 to pi. So let's try that. Like I will integrate both sides. Like I will write it in another row so it doesn't get messy. Integral from 0 to pi, 1 minus sine square of x dx. I will just call this alpha. I mean, it's already integrated, so just so I don't have to write a lot. I mean, we won't calculate this integral anyway because it isn't possible. I mean, with elementary functions, with special functions maybe, but okay, from 0 to pi, 1 minus sine squared of x plus sine to the power of 4x divided by 2 dx. Just so you don't, okay, where is dx? Dx is there, okay, or something. Okay, this looks fine. So what do we have to do now? We just have to evaluate those integrals. And how will we do that? I mean, this one is pretty simple. Looks like this integral, should be, of course, when we get something this here, some number, this one should be bigger because we have sine to the 4 of x divided by 2. This is a small number added to this integral, but it should be bigger, of course. I mean, because of the greater sign. So let's evaluate this integral. So this integral, I will call it, I don't know, maybe beta. So beta, I won't write it again. I mean, I will just integrate. This is a constant. This is pi minus and we will use the double angle formula, or whatever you want to call it. 1 minus cosine of 2x divided by 2, okay, sorry, divided by 2 dx from 0 to pi. Okay, and when we evaluate this integral, I mean, this is really a basic integral. Okay, this equals to pi minus pi over 2. Pi over 2. I mean, how can you evaluate this? This is like, you can get one half in the front here, and you will have like pi minus cosine of 2x. You can get a substitution. 2x equals t. It will get divided by 2, and it will be 2x. I mean, the sign, it will be like sine from 0 to 2 pi or something. So this isn't that bad to integrate, and we are left out with pi over 2. Okay. Okay, let me write, okay, and let me call this integral, I don't know, gamma something. So this integral, I mean, this part is the same like this part, like this one. So it will be pi over 2, right? Pi over 2, okay, what is this? Pi over 2 plus, so we will get pi over 2 from this one, of course, because it is the same like this. And this integral, like this integral, you can use the same trick as writing, I mean, sine of 4 to the power of 4x can be written as sine to the power of 2x to the power of 2. So you can write it like 1 minus cosine squared, I mean, not squared, cosine squared of x, but cosine of 2x divided by 2 and then squared. You can write it like this, and I won't calculate this integral, but because it is pure, it's really elementary, just it will take too much time to calculate it. You should get 3 pi over 16 from this one, from this, guys, from this one, the one I didn't calculate. So when we add those two things together, the common denominator is 16, of course. And when we multiply this by 8, we get 8 pi plus 3 pi, which equals to 11 pi divided by 16. And so this is what we got, which was the question we were asked. This integral is pi over 2, so pi over 2 is less than 11 pi divided by 16, and this integral is in the middle. And so that was it for this video. I hope you guys enjoyed this. This was a bit a weird question, not so typical integrating thing we usually do, because this integral cannot be solved. We had to approximate the integral with some inequalities, which I can prove if you asked in a video, but I already said it would get too long. So that was it for this video. Like, share, and subscribe if you want to see more of this, and see you in the next video. Bye, guys.